Hi everyone, this is your Srinivas Rao, Physics, NEET and IIT faculty. So, previous continuation, what is the previous continuation? Applications of contact forces. Let us continue the system of three masses. System of three masses based on how to get the acceleration, how to get the contact forces between the two surfaces. Two surfaces are in contact out of three blocks kept contact with each other along the horizontal surface. For the system of three masses M1, M2 and M3, how to get the expressions. So here three masses M1, M2, M3 are kept contact with each other along the horizontal surface. Let capital F be the applied force on the system of three masses. Your entire system accelerated along the horizontal surface or along the x-axis. First of all, we have to derive the expression for mass m1. Free body diagram for mass m1. So here m1 located along the horizontal axis, capital F directly axis with mass m1. The contact force exerted by mass m2 on m1 is F1. Here mass m1 accelerated along the positive x-axis. From this diagram, so here applied force F dominates the contact force F1. So we have to write the expression F net is equals to capital F minus F1. According to Newton's second law, F net is equals to M1A is equals to capital F minus F1. This is equation 1. Next, we have to write the free body diagram for mass M2. Imagine mass M2. In case of M2, two contact forces acts on it. One contact force exerted by mass M1 on M2, another contact force exerted by mass M3 on M2. So we have to write the F1 and F2 values. Based simplify the expression. So here mass M2 accelerated along the positive x-axis. F1 acts on M2 along the positive x-axis. F2 acts along the negative x-axis. Here F2 in a direction opposite to F1. Already said F1 be the contact force exerted by mass M1 on M2 and F2 be the contact force exerted by mass M3 on mass M2. But mass M2 accelerated along the positive x-axis. From this free body diagram, here contact force F1 dominates the F2. So we have to write F1 minus F2 is equals to M2A. This is equation 2. Next, third system of mass M3. We have to consider the free body diagram for mass M3. According to diagram, here applied force F not directly acts with mass M3. Only contact force exerted by mass M2 on M3. On M3 only. So the mass M3 accelerated along the positive x-axis. Here net force acts on the mass M3 is equivalent to contact force F2 only. So we have to write the expression F2 is equals to M3A. This is equation 3. For getting the acceleration of the entire system from equations 1, 2, 3, simplify the values, then we'll get acceleration of the entire system. From equations 1, 2 and 3. So first of all simplify the 2 and 3 equations. Instead of F2 substitute M3A, then we'll get contact force F1. F1 minus M3A is equals to M2A implies F1 is equals to A taken as common, so M2 plus M3 in bracket. So this is the contact force F1. This is equation 4. Next, substitute the contact forces F1 and F2 in equation 1, then simplify, we'll get the external force applied on the system of 3 masses M1, M2 and M3. How to get? Okay, check the expression. From equation 1 we have to write M1A is equals to F minus, instead of F1 substitute M2 plus M3 into A. Simplify this value, we will get applied force F is equals to M1 plus M2 plus M3 into A. This is equation 5. From equation 5, we can easily write the expression for acceleration of the system. From equation 5, we have to write the expression for acceleration of the entire system. A is equals to F by M1 plus M2 plus M3. This is the acceleration of the entire system of masses M1, M2 and M3 are contact with each other. This is equation 6. Substitute the equation 6 in contact force F1, we will get the expression for F1. F1 is equals to M2 plus M3 into F by M1 plus M2 plus M3. This is the expression for first contact force exerted by M2 and M3 on M1. This is equation 7. Second contact force F2 is equals to M3 F by M1 plus M2 plus M3. This is the expression for second contact force. So these are the expressions for 3 masses or 3 blocks contact with each other on a horizontal surface.